In this video, we're going to show you how to measure available voltage and voltage drop with an auto ranging meter. Now, this is the Fluke 87.5. In order to measure voltage, you're simply going to place the rotary dial on DC volts. The black lead goes in the common, and your red lead goes in the voltage position. Now, in order to measure available voltage, your black lead goes on ground, your red lead goes all the way to the top to the voltage source. And you can see we have 12.05 volts available. Now, a voltage drop test is a little bit different. It's going to measure how much voltage a component is using. So for instance, if I wanted to measure the voltage drop of the bulb, my red lead would go to the most positive side of the bulb, black lead to the most negative side. And you can see those numbers are very similar. Therefore, the bulb is getting all the voltage drop. All right, in this video, we're going to show you how to measure voltage, available voltage, and voltage drop with a manual ranging meter. First, with this style meter, you're going to look to see where DC volts are available and set it to the range. Now, keep in mind, the range is as high as the meter can go on that setting. So for instance, I have it on the 20 volt setting, which will easily handle 12 volts. As far as my meter leads, again, my black is on the common, my red lead is in the voltage position. Now, available voltage, I'm going to place my black lead on ground and my red lead to the voltage source. And there's my available voltage, 12.12 volts. Now, a voltage drop is a little bit different test. It's going to measure how much voltage it takes to operate or push through the resistance of a certain component. So if I wanted to measure the voltage drop of the bulb, my red lead would go to the most positive of the bulb, black lead would go to the most negative. And you can see most of the available voltage is being used by the bulb. Now, we could also measure the voltage drop of the other components. For instance, I could measure the voltage drop of this wire. And as you can see, the number is very low. So in this case, it would be a good idea to go ahead and range down into millivolts to get a better reading. So I moved it down to the 2000 millivolt scale. And doing a voltage drop, you can still see very, very low voltage drop, which again, that's what I want because very low resistance in the wire, therefore a very small voltage drop. All right, in this video, we're going to show you how to measure DC amps of this circuit. Now, the most important thing here is the meter setup. There are three things you have to do in order to measure amperage of a circuit. The first thing you're going to have to do is determine what scale you're going to put your meter on. Now, this is an auto ranging meter, the Fluke 87.5. I'm going to remove my red lead and I'm going to start with the large amp position. As you can see, this side of the meter is fused at 10 amps. Then I'm going to move my rotary dial because right now I have it set up on voltage. It's telling me that there's something wrong. So I'm going to move the rotary dial to measure DC amps, but notice this meter defaults to AC. So I'm going to have to hit the AC/DC button or the mode button to change it to DC. Okay. Now the third thing I'm going to have to do is make my meter part of the circuit. Now, what I could do is I could remove a piece of wire or a part of the circuit and place my meter in place of that wire. The bulb comes on, that means current flow is leaving my power supply, going through this wire, through the fuse, through the switch, through my meter, and measuring the amount of electrons, then through the bulb to ground. And you can see this one pulls about 250 milliamps or 0.25 regular amps. Now, if I wanted a more accurate reading, this particular meter is fused at 400 milliamps. So that would be 0.400. So this number is less than what the meter is fused at, so I could actually measure it on this scale if I want to. So I'm going to move my red lead over. Again, I'm going to make my meter part of the circuit. And you can see a little bit more of an accurate reading. Notice on the large amp scale, it rounded to 0.250, but a better number is 244.1 milliamps. Now, the other thing I could do in order to measure the amperage of the circuit is I could simply go across an open switch. So I could put my meter on the positive side of the switch and the negative side of the switch, and I get the same number. Okay, and that is how you measure amperage, DC amperage of a circuit. In this video, we're going to show you how to measure DC amps of this circuit with a manual ranging meter. Now, there are three things you have to do in order to measure amperage correctly of a circuit. First, you're going to have to put your red lead in the DC amps position, which in this case, this particular meter can measure up to 10 amps DC. I'm also going to look at the amperage scale of the meter, and I'm going to rotate my rotary dial. That's the second thing I need to do, to the 10 amp scale. Third thing, I need to make my meter part of the circuit. So in this case, I'm just going to remove this wire, and I'm going to place my meter in place of that wire to get an amperage number. You can see my bulb comes on, therefore current leaves my power supply, goes through this wire, through the fuse, through the switch, through my meter, through the bulb to ground. Now, we could also measure it across an open switch. So I'll put my wire back, turn my switch off, put my red lead on the most positive of the switch, ground on the most negative side of the switch, and you can see I get an amperage that way as well. All right, in this video, we are going to show you how to measure resistance of a component with an auto ranging meter. Now, the first thing you have to do with the component is you have to isolate it from the circuit, because the meter sends out a voltage to measure resistance. If I had this resistor as part of the circuit, I would also have voltage coming from the board or the power supply and my meter, and the meter would get very confused. Now in this case, I'm going to put my red lead in the ohms position, black lead on the common. I'm going to move my rotary dial to the ohms position, and I'm just simply going to measure in parallel across the component. And you can see this is about a 100 ohm resistor. Now with auto ranging, I can just go on down to the next one and see that this one's pretty close to 1,000 ohms, because it's 0.991 K ohms, which would be 991 ohms. And then I can go down to the last one, which is 10,000 ohms. So in this case, 9.98 K, which would be 9,980. And that is how you measure resistance of a component.
All right, let's do this. Got my meter set on amps. I know there's a lot of amps in this battery, so we're just gonna get it done. Positive, positive, negative, negative. See what we've got. Ah! Yeah.